Hello friends. So today we will discuss again on virtual network connectivity with peering. So we understand what is virtual network. So I am going to communicate between the two virtual network. For example, I have one virtual network and second one is another virtual network, and I want to make a communication between both of these two virtual networks. Virtual network is isolated environment where the resources cannot communicate with other virtual network, means other isolated environment. It can be possible via some connection between both of them. So Microsoft providing VNet peering between the two virtual networks, uh, whether it is in same region, it is in different region, or different subscription. Okay, so if the resources are in same region, so it is called regional VNet peering. Okay, regional VNet peering. And if we are going to peer the VNets, we are across the regions, means one region, one VNet in for example US East region, and second VNet in Canada Central region. So it is called global VNet peering if we are going to peer VNet. Okay, so what is the benefits of VNet peering? VNet peering enables you to seamlessly connect separate VNets with optimal network performance, whether they are in the same Azure region, okay, which is VNet peering, or different regions, that is the global VNet peering, okay. And network traffic between peered virtual network is always private, means they use the Azure backbone network. The virtual network appears as one of the connectivity purposes. The traffic between virtual machines in peered network uses the Microsoft backbone infrastructure and no public internet. There is no public internet connectivity like site-to-site VPN connectivity. There is publicly VNet public connection is there, and no gateway is required. Like site-to-site VPN connectivity, there is the VNet gateway is required. So here in virtual network connectivity, there is no uh, gateway is required. So virtual network peering enables you to seamlessly connect to Azure virtual networks. Once they are paired, virtual networks appear as one for the connectivity purpose. Means they can communicate each other over the Azure backbone networks, which is giving low latency, high bandwidth connection, ability to apply energy, ability to transfer data between VNet across region or subscription. And while during the peering of these two virtual networks, there is no downtime for the resources, whether the virtual networks are in different region or different subscription, it doesn't matter. Okay, so there is no outage. So these are the benefits. Okay, so for example, I am having two virtual networks. For example, I am having three virtual networks, two in same region and one is in cross region, another region, that is the South Central US region. Okay, so first of all, let's understand how to peer the same region, means regional VNet peering, how to do regional VNet peering. So go to the peering, now go to the add, name the peering. So I am regional peering, I am mentioning. Okay, so I am using the default setting like traffic to remote virtual network, traffic forward from remote network, virtual network gateway router server, peering remote virtual network peering link name. I am mentioning the same regional peering. Okay, so there are two methods. If I know the resource ID, I can mention that. If whenever you click that, you need to mention the resource ID. Otherwise, you need to mention the subscription, then virtual network, because I am doing for 01, 01 to 02. Okay, now add. So it is going to add between 02 to 01 and 01 to 02. So this is the way of the regional peering. Now, again, for example, this is the South Central US VNet, and I want to peer with another region, means global peering I want to do. So how to do it? Global peering. I am giving the name now. Same name I am giving, global peering now. So I think you have a question how to get this resource ID. So I will let you know how to get the resource ID. For example, I want to make this peering from with this EUS01. So in properties, you will get resource ID. So copy this resource ID and click on this and paste here. Okay. So this is the way you can do the global VNet peering. Now add. So you can see here it is immediately global peering. So there is no downtime, low latency, high bandwidth. This is very interesting. So if you go to virtual networks, now go to um, East US virtual network, you can see here in the peering, refresh, there is two VNet peering, regional peering with 02 and global peering with South Central US region. So this is the way how we create the VNet peering. Now, gateway transit and connectivity. So when virtual networks are peered, you configure the VPN gateway in the peered virtual network and transit point. For example, we can understand like this. There is virtual network and another virtual network and another virtual network and another virtual network and another virtual network. If I want to communicate with this VNet to this VNet, I need to do VNet peering. If I want to communicate with this VNet peering required. Here this VNet peering required. Here this VNet peering required. If I want to communicate with this one, then I need to do the VNet peering with this. I need to do VNet peering with this if we want to communicate between both of them. And between both of them, then this type. Let me make the naming VNet 1, VNet 2, VNet 3, VNet 4, and VNet 5. So these are the 5 VNet, and if we want to communicate, this is the VNet peering is required. But if your environment is very large, because in production, there are thousands of VNet and they wants to communicate to each other. So how they will connect? It will so messy. So how we will do the communication between them? So we will use the hub spoke model. Okay, means one VNet is working as a hub. Let me draw another diagram. This is the hub, and these are the spokes like that. Okay. So if there is on-prem environment wants to connect using there is express route connectivity or site-to-site VPN connectivity. Okay, there will be a gateway here also. So they will communicate like that, and there will be the gateway subnet, and there is the virtual appliance, and we need to do the VNet peering. One moment. We need to do the VNet peering with this hub, and these are the spokes like that. It is not only sufficient. We need to do the UDR, user defined routing. Okay, so how we do the user defined routing? We will create a network virtual appliance here. This virtual appliance may be the Azure firewall or maybe the Palo Alto firewall, and all the routing going to the next hop is virtual appliance, and virtual appliance will uh, route all the traffic to different one. So for this, we will do the user defined routing. Also, if we do the gateway transit, then there will be connectivity. If, uh, for example, there is a gateway subnet. So gateway subnet could communicate, use a site-to-site VPN to connect to an on-prem network, or VNet to VNet connection, another virtual network, or point-to-site VPN connection to client. So we need to enable gateway transit if we want to communicate throughout the this on-prem to other VNet, or other VNet to on-prem, or VNet to VNet. Okay, so this is the concept of gateway transit connectivity. So if we are going to simplify, we need to use hub spoke model, and there should be a gateway subnet or VPN gateway, and we need to allow gateway transit. Okay, so it's all about today's session. Please like, subscribe, and share this video. Thanks all of you.